Hi friends, welcome to this video on packet tracer activity, pinging and tracing to test the path. We will come to this packet tracer objectives. In part 1 we will test and restore IPv4 connectivity. In part 2 test and restore IPv6 connectivity. Also we will go through the scenario here. There are connectivity issues in this activity. In addition to gathering and documenting information about the network, we will locate the problems and implement acceptable solutions to restore connectivity. Also, given a note here, the user exit password is Cisco and privileged exit password is class. Right. Now we will come to part 1, test and restore IPv4 connectivity. In that step 1, I use ipconfig and ping to verify connectivity. Click PC1 and to click the desktop tab, command prompt, enter the ipconfig space /all command to collect the IPv4 information. Right, we have to get the information from PC1. Complete the addressing table with the IPv4 address, subnet to mask and default gateway. Yes, if you observe this addressing table here, we can see we have to complete all these informations. You have to collect information from PC1, PC2, PC3 and PC4, and we have to update this table, right? Also we have to collect the information. Click PC3 and to click the desktop tab, command prompt, enter the ipconfig /all command to collect the IPv4 information. Complete the addressing table with the IPv4 address, subnet to mask and default gateway. Then finally we have to test connectivity between PC1 and PC3. The ping should fail. Right, we will do this now. Here is our PC1. We'll go to desktop, command prompt. Here we are going to give ipconfig all, and here we can see the details, IP address. Here we can see the subnet to mask, and here is the default gateway. Right. Also we will verify on PC3. Desktop, command prompt. Here we are going to give ipconfig space all. Here we can see the address, IP address, subnet to mask. Also we can see the default gateway. Right. Here we can see our addressing table, and we updated the details of a PC1 and PC3. Here we can see the IP address, subnet to mask and the default gateway. Now we are going to ping from this PC1 to PC3. So coming to PC1, command prompt. Here we are going to ping to PC3 IP address. We are getting destination host unreachable. Now we will come to step 2, locate the source of connectivity failure. From PC1, enter the necessary command to trace the route to PC3. What is the last successful IPv4 address that was reached? Alright, we will verify that. We will come to PC1, command prompt, and here we are going to give the command trace it and PC3 IP address, and we are going to press enter now. We go 10.10.1.97. Then we are waiting 10.10.1.97. Then request timed out. So this is the again same IP address we are getting. This might be the last successful IPv4 address. Right, here we can see the last successful IPv4 address that was reached is 10.10.1.97. Next is the trace will eventually end after 30 attempts. Enter Ctrl+C to stop the trace before 30 attempts. Right. Then the next is from PC3, enter the necessary command to trace the route to PC1. What is the last successful IPv4 address that was reached? Right, we will try that. Enter Ctrl+C to stop the trace. Right, we will try this now. Before going to that, in the previous tracer we have seen the last successful IPv4 address was reached 10.10.1.97, and here we can see that IP address is the address of this interface gigabit Ethernet 0/1 on this device R1. Now we will give the tracer command from PC3 to PC1. Before that, we will get the IP address of PC1. Here is that. I'm going to copy this address. Right. Now we will come to PC3 command prompt. Here we are going to give tracer and PC1 IP address. Right. So here we get the IP address 10.10.1.17. So this will be the last successful IPv4 address reached. That is 10.10.1.17. Here we can see this IP address is of gigabit Ethernet 0/1 on on the device R3. Yes, so when we trace from PC1 to PC3, we have seen the packet reached from PC1 till this R1 interface gigabit Ethernet 0/1, and from PC3 to PC1 the packet reached from till this interface gigabit Ethernet 0/1 on R3. Now we will come to the next, click R1 and then the CLI tab. Press enter and log into the router. Enter the show IP interface brief command to list the interfaces and their status. There are two IPv4 addresses on the router. One should have been recorded in step 2A. What is the other? Right, we will verify that. Coming to R1 CLI. Right, we will press enter. Enable. Now we are going to give the command show IP interface brief, and here we can see two IPv4 addresses, 10.10.1.97. yes, this address we have been recorded in our spreadsheet as a PC1 default gateway, and this is the address, yes, 10.10.1.6. Now we will go to G. Enter the show IP route command to list the networks to which the router is connected. Note that there are two networks connected to the serial 0/0/1 interface. What are they? Right, we will verify that. Coming to R1. So here we are going to give show IP route, and here we can see. Here we can see there are two networks connected to the serial 0/0/1 interface. We can see that 10.10.1.4/30 and 10.10.1.6/32. Now we will come to H. Repeat step 2E to 2G with R3 and record the answers here. Notice how the serial interfaces for R3 changes. Run more tests if it helps visualize the problem. Simulation mode is available. Right, so we will do it on R3 now. Coming to S3 CLI. Right, enable. First we are going to give a show IP interface brief, and here we can see the address 10.10.1.17. This is the address being noted in our spreadsheet. This is the default gateway of PC3, and here we can see the other address 10.10.1.10. Next we will give the command show IP route, and here we can see the two addresses which is connected to serial 0/0/1. That is 10.10.1.8/30 and 10.10.1.10/32. Now we will come to step 3. Propose a solution to solve the problem. Compare your answers in step 2 to the documentation you have available for the network. What is the error and what solution would you propose to correct the problem? Right, we will check this now. Okay, we will check from the topology, so it will be more easier. Here we can see the network in between the router R1 and R2. Here the used network is a 10.10.1.4/30. Here the CIDR is 30. That means here we have two usable IP address. That is 10.10.1.5 and 10.10.1.6. So these are the two address can be used. So here on R1 for this interface, so that is serial 0/0/1. Here we can see the IP address that is 10.10.1.6. Okay, it's correct. So obviously the IP address for this interface, that is serial 0/0/0 on R2 should be 10.10.1.5. So we have to verify that. Coming to CLI, enable show IP interface brief. Here we can see that yes. So here the IP address of this interface serial 0/0/0 on R2 they given wrongly. So this address belongs to some other networks 10.10.1.2. So this address should be 10.10.1.5. So we have to change this address. We have to change this address of this interface serial 0/0/0. Now we will come to step 4. Implement the plan. Implement the solution you proposed in step 3b. Right. Here the solution is we must change the IP address of this interface serial 0/0/0 on R2. Right. We will change that. Coming to CLI, configure terminal. We have to go to the interface. Serial 0/0/0 and we are going to set the IP address 10.10.1.5 and here we have to specify the subnet mask that is 255.255.255.252. yes, and now we will cross check it. Show IP interface brief, and here we can see that. Now we will come to step 5. Verify that connectivity is restored. From PC1 test connectivity to PC3. From PC3 test connectivity to PC1. Is the problem resolved? We have to verify that. Coming to PC1 command prompt. Now we will ping to PC3. Yes, here it is. Yes, we are getting the replay. Now we will go to PC3. Yes, command prompt. We are going to ping to. Right. So we will get the IP address of PC1. Command prompt. Here we can see. I'm going to copy that. Coming to PC3 command prompt. Here we will give a ping. Yes, we are getting the replay. Now we will come to step 6 here, document the solution. Anyway, we implemented the solution here. Now we will come to part 2, test and restore IPv6 connectivity. Use IPv6 config and ping to verify connectivity. Click PC2 and click the desktop tab. Command prompt, we have to give the command IPv6 config/all. Command to collect the IPv6 information. Complete the addressing table with the IPv6 address, subnet prefix and default gateway. Also we have to get the information from PC4. Give IPv6 config /all command to collect the IPv6 information. Complete the addressing table with the IPv6 address, subnet prefix and default gateway. Test connectivity between PC2 and PC4. The ping should fail. Right, we will do this now. Coming to PC2 command prompt. Here we are going to give IPv6 config all, and here we can see the address, IPv6 address, then default gateway. Right, and we will come to PC4 desktop command prompt, and here we are going to give IPv6 config all, and here we can see the details. Okay, we will update this information into our addressing table. Yes, here we can see the details updated in our addressing table. PC2 and PC4 IPv6 address and default gateway. Now we will ping from PC2 to this PC4. So coming to PC2 command prompt, here we are going to give the IPv6 address of PC4. We are waiting for the reply. Request timed out. Here we can see the ping is unsuccessful. Now we will come to step 2. Locate the source of connectivity failure. From PC2, enter the necessary command to trace the route to PC4. What is the last successful IPv6 address that was reached? And the trace will eventually end after 30 attempts. Enter Ctrl C to stop the trace before 30 attempts. Right, we will trace from this PC to PC4. We will give the tracert command on PC2. Coming to PC2 command prompt, here we are going to give a tracert and the IP address of PC4, and here we are waiting. Here we go to 2001:db8:1:3:2. So we are waiting for the tracer to request timed out. Right, okay, request timed out. So here we can see the last successful IPv6 address reached is 2001:db8:1:3:2. Right. Yes, so this last successful IPv6 address 2001:db8:1:3:2 is the IP address of this interface, that is serial 0/0/1 on R3. Yes, here we can see that. Yes. We will come to C. From PC4, enter the necessary command to trace the route to PC2. What is the last successful IPv6 address that was reached? Yes, we will verify that. Enter Ctrl C to stop the trace. Right. First of all, we will get the IPv6 address of PC2. Yes, here it is. We will copy this. Coming to PC4 command prompt, here we are going to give tracert, then IPv6 address of PC2. Here we can see that. Oh, here we can see no IPv6 address was reached. Next is click R3 and then the CLI tab, press enter and log into the router. Enter the show IPv6 interface brief command to list the interfaces and their status. There are two IPv6 addresses on the router. One should match the gateway address recorded in step 1D. Is there a discrepancy? We will see that. Run more tests if it helps to visualize the problem. Simulation mode is available. Right, we will verify this now. Coming to R3, right, enable, we will give the show command, show IPv6 interface brief, and here we can see the details. Okay, now we will compare with our addressing table. Here we can see the interface serial 0/0/1. Here we can see FE80:3, but we given the default gateway as FE80:2. So that should be :3. So the PC4 default gateway we must change. So here is the problem. Now we will come to step 3. Propose a solution to solve the problem. Compare your answers in step 2 to the documentation you have available for the network. What is the error? Yes, just now we have seen that PC4 is using the wrong default gateway configuration, so we must change that. Yes, what solution would you propose to correct the problem? Obviously we must change and we must configure PC4 with the correct default gateway address, that is FE80:3. Now we will come to step 4, implement the plan. Implement the solution you proposed in step 3b. Right, we must change this PCB IPv6 default gateway. Here we have to give FE80:3. Yes. Now we will come to step 5, verify that connectivity is restored. From PC2 test connectivity to PC4, also from PC4 test connectivity to PC2. Is the problem resolved? We will verify that now. First of all we will ping from PC2 to PC4. So here is that ping. Yes, we are getting the replay. Now we will ping from PC4 to PC2. Before that we will get the IP address of PC2. Yes, here it is. We will copy this address. Right, coming to PC4, command prompt. Here we are going to give IPv6 address of PC2. Yes, we are getting the replay. And here is our last step, document the solution. Right, so we implemented the solution. Well friends, that's all in this packet tracer activity, pinging and tracing to test the path. And in this activity we have seen how to gather the information. Also we have seen ping and trace using IPv4 and IPv6 address. Friends, if you have any doubt, please comment below. Also, if you like my video, give a thumb. And don't forget to subscribe the channel so that you will get latest uploading video info into your Gmail. Thank you.